Good morning, students. I am Shukra Banerjee, Associate Professor of Department of Pharmaceutical Chemistry, University. Wants to deliver a topic on urinary tract anti-infective agents. So that is coming under 601, medicinal chemistry. So you should study about this drug. So first of all, we should know what is urinary tract anti-infective agents. So this is one of the important categories of the drug which can treat the urinary tract infection. So first of all, you should know what is urinary tract infection. UTI are common infection that happen when bacteria often enter through the skin or rectum, enter the urethra and infect the urinary tract. The infections can affect several parts of the tract, but the most common type is the bladder infection, that is cystitis. That is, cyst can form in the urethra also. See, the kidney portion is situated in the lower extremities in the backside. So here infections are causing, and there is inflammation, pus secretion, pain, and sensation of itching and some uncomfortable sensation during urination. So these are the urinary tract infection. So this is infection caused by E. coli. So E. coli is a type of bacteria commonly found in the gastrointestinal tract. So what are the symptoms of urinary tract infection? So pain or burning sensation when peeing or glycine. That means when squirting urine, you can get the pain sensation. Needing to pee more often than usual during the night. Generally, you have a tendency to secrete frequently, generally in the night also. So that is known as a nocturnal. Pee that looks cloudy, dark, and has a strong smell, like urine. That is secreted. It is cloudy in nature because the bacteria are present and dark and it's a strong smell. So needing to pee suddenly or more urgently than usual. So in sudden cases or in unusual cases, there are types of infection. Needing to pee more often than usual. Usually, people having 3 to 4 hours of urination during the interval of the urination, but they will be unusual urination. So, going to the treatment. So, quinoline, that is a category of the drug which constitute a large class of synthetic antimicrobial agents that are highly effective in treatment of many types of infectious disease, particularly those caused by bacteria like GI. So, quinoline are potent broad spectrum antibacterial agents. So, that that can kill a different range of bacteria. So the early originator of this category is malolactic acid, which is limited to certain gram-positive infections such as UTIs. However, the modern generation of quinolone, that is one of the derivatives of the malolactic acid, containing 6 fluorosubstituent and cyclic basic amine moiety C7, surpass their predecessors in terms of spectrum of the active ingredients. So this has allowed for their use against a variety of gram-positive as well as gram-positive pathogens. Now, I'm going to the next structural category. So that means the malolactic acid, the first category, where the 6-fluoroquinoline, that is the fluoroquinoline, is one of the important category, which is causing more important infection, and they can be used for the treatment also. Okay. Now, just next, we are going to causes and symptoms, that is already discussed, and treatment, whereas malolactic acid drug. Then mechanism of action. Then quinoline inhibit the action of bacterial DNA guides, that is the enzyme that is present in the that is for the DNA synthesis. So that inhibit the bacterial DNA guidance enzyme. So that enzyme what plays the role? That enzyme is responsible for supercoiling and compacting the bacterial DNA molecules into bacterial cell wall during replication. So the action is accomplished by modifying the topology of the DNA via supercoiling and twisting of this macromolecule to permit DNA replication or transcription. That means the DNA will not be replicated or transcripted, as well as the bacteria will be dying. So this is used for the upper and lower respiratory tract infection, gonorrhea, bacterial gastroenteritis, and soft tissue infections, UTI, bone and joint infection, and tuberculosis also. Next, I'm going to the structure of quinoline and quinoline. See the structure quinoline, you can draw in also. See, quinoline having a two nitrogen containing cyclic rings are fused together, and starting from the nomenclature from the 1, 2, 3, 4, 5, 6, 7, 8. At the third position, there is a carboxylic acid. Fourth position, there is a oxo group. And at the seventh position, there is a methyl. And at the 1 and 8 position, nitrogens are there. So that is known as a quinoline, and this drug is known as a nalidixic acid. Whereas this, all the parts playing important CH2. Now there is fluoroquinoline derivatives that at the 7th position, there are some substitution where the two nitrogen compounds as a bicycle, and there is a fluoro ring at the 6th position, that is known as a fluoroquinoline derivative. And it is also containing same molecule, same the 1 and 3 and 4. Okay, but there are some R and R1 that can be substituted. So this is not having broader category. Next, coming to the next slide. So this drug basically plays important, and there are different derivatives of this drug. See the derivatives. See the structure in this image. See, you can see, and there is 8 at the 8th position of the nitrogen, and R6 and R7 substituents are there in the R6 and R7 position where nitrogen is not mentioned. Okay. So depending upon the X and the R6 and R7, the drugs is given different type of name, like the nalidixic acid, enoxacin, norfloxacin, ciprofloxacin, amifloxacin, saprofloxacin, okay, and lomifloxacin. So these are the important drug which plays important function, whereas norfloxacin, ciprofloxacin, saprofloxacin is important drug, amifloxacin. Okay. Next, going to the structural continuation. So if the X, that is the 8th position, chlorofluoro group is there, chloroxacin, and X position, CCOCH3, that is the carboxymethyl group, that is known as the catifloxacin, one of the very category for the bacterial or antifungal infection for the eye also. Okay. And some higher category ciprofloxacin is also there, where R1 and R7 is changing. Sorry, there are some changes known as the R1 and R7. That is known as the R1. Coming to the nalidixic acid, the structure is shown here, and the IUPAC name. So it is known as the 1-ethyl. See the nomenclature: 1, 2, 3, 4, 5, 6, 7, 8. 1-ethyl, 1,4-dihydro at the 1 position. Hydrogenation is there. 7-methyl, 4-oxo, 1,A naphthyhydride, the naphthyl ring. That's why it's known as a naphthyhydride. 3-carboxylic acid. Okay. Next structure to relationship. So if we go for any changes with this drug, like the 1,4-dihydro 4-oxo-naphthyhydrogen, 3-carboxylic acid moiety is essential for antibiotic. So prototypic drug of this category is nalidixic acid. So this drug is the most prototypic category. Side chain of the nalidixic acid can be modified to give drug sunilic acid having action similar to nalidixic acid. That means there are some side chain can be produced in nitrogen at the 8th position, and there may be some another ring in position, that is oxonilic acid, may have some action similar to that of the nalidixic acid. Okay. So presence of CWH group at the 3rd position is very essential for DNA guidance binding and bacterial transport. So modification of this or removal of this group abolishes that. That means if the 3-carboxylic acid group is modified or added, then the activity will be lowered. So introduction of the fluoro group at the C6 position and piperazine ring at C7 gives highly potent drug like the ciprofloxacin and norfloxacin. So if we go for the structural modifications like the norfloxacin, see that is piperazine ring, 2 nitrogen containing saturated heterocyclic molecule is known as a piperazine, and fluoro group that is known as a ciprofloxacin, one of the very good important category. Okay? Norfloxacin also. Substitution of C7 and C8 position and controls the potency and the pharmacokinetic of the drug. Introduction of the fluorine at the C6 and C8 gives ciprofloxacin. The C6, C8 position, if fluorine is introduced, then the drug will be known as the sparefloxacin, which is a broad spectrum antibiotic. Fourth position, subgroup is the pyrroline nucleus appears to be essential for the antibacterial activity. Replacement with the 4th thioxo or sulfonyl group leads to loss of activity. Sometimes it has been tried that if we put sulfur to that position, then if you want to see the activity, but it has been found that drug activity has been. The incorporation of an amino at the C5 position here has proven beneficial in terms of antibacterial activity. That means amino group can produce another type of category. A halogen, that is fluorine or chlorine at the 8th position, okay, at this position has proven beneficial, improves the oral absorption also. So as a result, ciprofloxacin and norfloxacin play category. The joining of the N1 group at the C8 position with oxazine ring leads to active ufloxacin. Ufloxacin is important drug. There another C8 position, there is an oxazine ring which will be providing important action. So nalidixic acid, again we are highlighting about the properties. See, it is white or pale yellow crystalline powder, typically soluble in water, but solution of hydroxide. It gets metabolized in liver to form an active metabolite, hydroxynalidixic acid, which further gets metabolized by glucuronidation to give inactive metabolites. Whenever the drug goes in the body, they go for the glucuronide modification. Okay. Next, uses primarily used as urinary antiseptic as a second line drug. Treatment of lower UTIs caused by E. coli, employed in the diarrhea caused by protease, E. coli or Shigella. So this type of infection can be treated by this drug. Next, going to the next slide. Norfloxacin, C at the 7th position, 1 piperazine ring is there. And if we make nomenclature of this drug, structure, 1 ethyl 6 fluoro 4 oxo 7 piperazine, 2 nitrogen containing saturated heterocyclic ring is a piperazine. It occurs as a white to light yellow crystalline powder. It is highly soluble in water, acetone and carbon tetrachloride. That is important category. Okay. Next, if you use this drug in case of UTI and E. coli, that is very good. And this drug is playing very important role in prostatitis, gastroenteritis. Norfloxacin is a very category of drug. Now, enoxacin, that is one of the important categories, the drug for this category. But this drug's marketed formulation is not so much. So, we are not highlighting on this drug. So, there are some substitution in different positions, just only. Ciprofloxacin, that is one of the very versatile used drug. That is also 1 piperazine is present in the 7th position. It occurs as white to crystalline powder. It is soluble in water but slightly soluble in ethanol. It is used for the treatment of UTI and chronic prostatitis, acute diarrhea caused by E. coli, treatment of pneumonia, skin infection and meningitis, and typhoid fever, tuberculosis and gastrointestinal. So this type of infection can be treated. So ciprofloxacin is very important drug for the treatment of UTI, chronic prostatitis, acute diarrhea, E. coli, pneumonia, skin infection, and meningitis, typhoid fever, tuberculosis, gastroenteritis. So, as this drug having a broad spectrum antibacterial, this drug can be used for different infection also. So, next category, we are going the synthesis of ciprofloxacin that will be discussed in your class. Okay, that you should study for thoroughly. Synthesis of ciprofloxacin. Okay, contribute. So, coming to the ofloxacin, that is one of the category that is also like the ciprofloxacin category. That is also very good category. It is a pale yellow or bright yellow crystalline bright powder, slightly soluble in water available and soluble in glacial acetic acid also. It is useful in the treatment of genitourinary tract infection, respiratory infection, gastrointestinal, skin and soft tissue infection, and gonorrhea also. Lamifloxacin, that is one of the newer category of antibiotic that is used recently, has been started its use. Pale yellow crystalline powder, and treatment is for the acute UTI caused by E. coli and treatment of bacterial infection in bronchitis and respiratory tract infection also. Sparofloxacin, that is also discussed in this category of the non-anorexic acid category, where it is also occurs as a crystalline powder. This practically insoluble water, sparing soluble but soluble in dilute alcohol also. It is also treatment of UTI, treatment of bacterial infection in bronchitis and respiratory tract infection. Datifloxacin, you can see that is already said it is a very antibacterial for eye infection, skin infection, bronchitis. See where the nitrogen contains 3 piperazine ring also. Piperazine ring also, and cyclopropyl ring is present at one position, datifloxacin. So none of the drug is 1 cyclopropyl. At the one position, cyclopropyl ring is there. 6-fluoro, 8-methoxy. At the 8 position, methoxy is there, CH3, and 3-methyl piperazine. 7 is a 3-methyl piperazine. Here is a methyl group, that's why 3, 1, 3. Piperazine ring is there. 4-oxoquinoline, 3-carboxylic acid. It occurs as a white crystalline powder. It is practically soluble in water. It is used in the treatment of urinary tract infection, treatment of bronchitis, sinusitis, and skin infection. Banned in India because of prolongation of hypoglycemia, arrhythmia, and phototoxicity since March 2008. The drug has been banned for the oral absorption because there are some hypoglycemia. There is hypoglycemia and arrhythmia of the cardiac system and phototoxicity also. Okay. Next, coming to the moxifloxacin, that is also important category of the skin infection as well as eye infection. So, datifloxacin here you can see it can be used topically for the eye. So, oral tablets are not so much used. Okay, and moxifloxacin, white crystalline powder, soluble in water, DMSO, and alcohol, primarily used for pneumonia, bronchitis, and used for treatment of acute UTI, treatment of conjunctivitis and bacterial infection and skin infection. Most potent like fluoroquinolone, and this is also used sometimes for the tuberculosis also. So some miscellaneous category of the drug are there, furazolidone and nitrofurantoin methamine. So among this category, nitrofurantoin is one important drug. Furazolidone structure you can see. Nitrofurantoin, very important drug. See the structure where it is known as a 1,5-nitrofuran. This thing is known as a nitrofuran. Okay. And 2-methyl thanoamino imidazolidine ring. Imidazolidine ring, this ring is furan ring, and 2,4-diamine. Okay. Nitrofuran, group is there, so nitrofuran ring and imidazolidine ring. Okay. And it occurs as a unocrystal, beta taste, and odorless, very slightly soluble in water, primarily bacteriostatic. Nitrofuran is activated inside bacteria by reduction by the flavoprotein nitrofurantoin reductase to unstable metal. That means this bacteria can undergo activation in the bacteria and disrupt the ribosomal RNA, DNA, and other intercellular components. It is bacterial, especially to bacteria present in acid. Treatment of UTI caused by E. coli, enterococci, and Staphylococcus aureus. Okay. Next, synthesis of nitrofurantoin. on the category that is study class. Methanamine, hexamine, one of the category that is synthesized in our lab also, that is for the methanamine, hexanamine, where hexa group is there and amine is present, that's why hexanamine. This occurs as white crystalline powder or is hydrogen, very soluble in ethyl acetate form. It gets metabolized in the liver by hydrolysis to keep the formaldehyde, which is an antiseptic. It decomposes slowly in acidic is formaldehyde, which is cell treatment. It's used for the treatment of resistant type of infection. Then, if these some of the respiratory tract infection or UTI is occurring again and again, this drug can be used. So, thank you everyone. Thank you for this slide sharing and thank you for the attention. Study more. Thank you.